Hey everybody, this is Larry. This is me over Q4 of the weekly contest 447 Path Existence Queries in the Graph 2. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this one. So this one is definitely tricky. I'm going to explain this in a couple of ways. I didn't end up solving this, but honestly, I had 95% of this problem solved in about 20 minutes. So if you want to watch the live portion, do that. But I'm going to do this breakdown, this breakdown I'm going to try to explain the right answer, the solution that I prefer, and I'm going to go over what I did wrong, right? And for me, honestly, it was a good learning experience because I did mess up something that I'm just a little bit out of practice. Like I had the ideas and everything correct, but there was just a little bit thing that well, sometimes you're off by one because, well, you're just off by one, typo or whatever. But sometimes you're off by one because you didn't analyze the understanding or visualization or whatever, and something's just really off because, well, you were never gonna get it right because you just misunderstood some part of it by a little bit, right? Anyway, okay, so what was the hard part about this problem? Let's actually give the more preferred solution. Okay, so this one, like I said, you can watch the live portion later if you prefer, but let me draw it out real quick. And I want to say, this is a harder version of the Q2 in many ways. I think y'all, watch that video just to make sure that we're on the same page and understanding what we want to do for this problem, right? So the first thing that I want to say is that the input is not sorted, but that doesn't matter, right? Because all you have to do is sort it, right? I mean, the only thing with sorting is that the queries at the end, there may be a little bit nuanced, but all you have to do is just keep track of it. So without loss of generality, we can do the same thing, but we don't sort it, right? Or sorry, we do sort it. We assume that it is sorted, all right? So then now here we have a number line again, and then we have some points. And here we're trying to find, let's say we have some points, right, of some distance. And now we're trying to find, okay, let's say we have this and we have this, and we're trying to find the minimum number of jumps. And of course, this is kind of maybe tricky because in this case, this is connected to this, but you want to go as far as you can, right? You want to go as far as you can on one jump, every jump really, and then you do n jump. But of course, if you're a little bit careless, you cannot do this with like n square or something like that. So if you analyze your ideas, and you can definitely do n square by accident. So the first part of this is a data structure. But really it's just the idea of it, and the data structure is sparse table, right? The sparse table is a very cool thing that honestly the name is really cool sounding, etc. But actually, honestly, during the contest, during the live solve, I forgot the name, and I was just like, I forget what it's called. It's like binary something. I called it. That's what I was saying. I was calling it binary something. But that's what I mean is that, like, you can know the names of all the flowers in the world, but it doesn't tell you how it smells, right? You have to, it's more important to know and understand ideas, because you're not trying to it's not trivia, it's solving, right? And anyway, for this particular problem, the idea that I even though I forgot the name because it's been a while, is just this idea of I call it sparse table, but basically the way that I would think about it, and that I would like to teach it, maybe for now, let me know in the comments with specific questions that you might have, is that, okay, well, let's say we do an n squared dynamic programming. What would that look like? Well, one way that you can think about looking at, there are a couple of ways you can think about it, but one way that you can look at is that, okay, let's just look at this first node for example, right? Then now you go, okay, what is the farthest that it can go on one jump, right? Maybe for this one, that's a little bit too short. Maybe for one jump, this is the biggest node. And then maybe for 2 jump, it is up to here. And then now for 3 jumps, it is up to here, and then 4 jumps up to here, right? And then so forth, right? And then maybe this just dots, but and maybe there's more, but right? And then all the way up to n, because, well, if you're not getting it in n jumps, you're not getting it, right? So okay, right? And of course, right? So this is how you think about it in n square, right? Because there are n number of things, or there are n for each node, and there are n nodes for each node. There are n things to look up, so you can build an n by n matrix, right? And then the way that you would think about it, maybe if you want to solve it, is that okay? Well, you look at, I don't know, there are a number of ways you can do it, but now if you were to solve this one and you have to query for it, then maybe you just go like, okay, you need this node and this node. Then maybe you just go to here, look up these things, and then just find one, maybe binary search or something that fits. Maybe well, technically, I guess it's this one actually, right? And then now you binary search for the smallest number of hops that gets you there, and that's fine, right? So that's how you do the queries. But how you do the construction? So the DP construction is actually not that bad, right? DP is, I mean, there are a number of ways you can do it, but you can say, okay, well, how do you get the two jump? Well, the two jump is just the one jump plus one more jump, right? How do you get the three jump? Well, the three jump is the two jump plus one jump, right? How do you get the four jump? The four jump is just the three jump plus one jump. And then five, maybe, I guess, I mean, you can't do one jump from here, maybe you could say. And then, so that's why, it's still here, and so forth, right? Okay. Yeah. So that's how you would do it, and then you do look up binary search. Maybe you could even do a little bit better, depending on how you want to construct it and pre-processing it and what so forth. Because maybe you could now do a reverse pre-process because you have n square space anyway. Your n is small, you're fine. But for this problem, you can't do that, right? Because n is large. N is 10 to the 5th, I think, right? And yeah, 10 to the 5th. So 10 to the 5th times 10 to the 5th is way too big. So then the idea behind binary, people call it binary lifting, maybe binary jumping, sparse table, all these things, right? Is that okay? Well, how do we reduce this to log n? Well, all we have to do is, let me actually move this around real quick. All we have to do is that given this thing, sorry, hang on, technical difficulties. Let me use the mouse. Okay, let's just say we have this, right? Okay, so let's say we have this, right? And maybe I'll draw this out a little bit more. Give me a second. Right, so like this is 6, 7, 8, 9, ... n, right? Well, the key idea here is that, well, we don't need all of these. And this is a 6, that's a terrible, right? We don't need all of these. We just need the power of 2's, right? So then now we don't construct this, we don't construct this, we don't construct this. So then now, let's rewrite this, right? What we do now, instead of constructing everything one by one, and this is for every node, remember, is that, okay, we construct it for 1, this is this, and then we construct it for 2. Well, how do we construct it for 2, right? Well, 2 is pretty straightforward. It's just that you move this by 1, and then you move this by another 1, right? Okay, well, how do you do it by 4, right? Well, 4 now is that you jump this by 2, and then you jump this by another 2, right? Because we know that if we process this in the right way, we also have the jump of 2 available. And then 8 is the same thing, right? We know that the 4 will be available here, and then 16, and then so forth, and then all the way up to n. Right? So that's basically the idea. And then the idea here is that then now for each node, we have log n levels, right? We have log n of these. So for each node, it's going to be n log n. Now, space and calculation, right? Because each calculation is O of 1 because you're just taking 2 pieces and then adding them together. It's not, it's kind of like adding them together, but you're merging them together with some function, right? So n log n time and space, right? So that is basically the core idea of sparse table. And so I got this, and then the question is, how do you do queries, right? That's the tricky part. And the answer is, well, with a binary walk, right? Binary search walk or whatever. I don't know. I feel like every time I call it divide and conquer, someone can use it more, but I still call it divide and conquer. It's just a walk. Either way, right? So basically, the idea is pretty, actually, let me redraw this a little bit first, right? So, okay, so then the idea here is that, okay, let's say you have 1 for 1, You have one for 2. You have one for 4. You have one for 8. And I'm just, it doesn't relate to this. It's just like I'm drawing them out for visualization, right? Okay, right? Dot, 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 n, right? And then the idea here is that, okay, ignoring bigger numbers for now, we'll just go up to 32, right? Then the idea here is, okay, these are the number of jumps, right? So then the idea here is just walking it. It's going, okay, if we, let's say we have, how do I want to say this? Let's say we have 64 things, right? Okay, so maybe this, we have to, how do I shrink this? I wish I could shrink this a little bit. Okay, fine. I don't know how to shrink this. Okay, well, that doesn't shrink it. Sorry, friends. Technology, who knows? Okay, anyway, okay, fine, we'll just skip the 32, we'll do 16. So let's say we're at 32, right? However, we go, okay, well, so then the question is just asking, do we need, so let's say we have n is equal to, currently we're at 32, right? What does that mean? That means that, okay, we have 32, and we're trying to go, this is a binary search. Okay, let me rewrite this. So this is just a binary search, right? We go, okay, well, is it from 1 jump to 32? Well, okay. And then you divide this half in a binary search to 1 to 16 or 17 to 32, right? So that's basically the core part of this idea is that, okay, well, how many moves does it take? Well, the number of moves that it takes is it in 32 moves? Let's just say the answer is yes. If you cannot do it in 32 moves, that means that, let's say n is equal to 32, by the way. Sorry, maybe I didn't say it this way. Let's say n is equal to 32. If you cannot do it in 32 moves, that means that the graph is not connected, so then you return -1 or whatever, right? Okay, let's say that it is that n 32. That means that you can't do it in 32 moves. Then now you could ask yourself, okay, well, to be refining it, and this is just binary search, which is that can we do it in either 16 or can we do it in either 1 to 16 moves or 17 to 32 moves, right? And that's basically looking at this. That's basically looking at this thing, right? And how far we have to jump. Okay, in 16 moves, we're able to jump to here. So if our query is getting from here to say here, then it is in the 16 side. If it is getting from, let me change the colors real quick. If it's from here to here, then it has to be more than 16 moves, right? So that's basically the idea behind this binary search is that, okay, we just try to figure out, okay, we know that it is from 1 to 32 moves. We just have to figure out if it's 1 to 16 moves or 17 to 32 moves by this query somehow, right? By looking at, okay, after 16 moves, it goes to here, right? And then if it's on the 17 to 32, then what does that mean, right? This means that you're trying to go from 17 to 24, maybe? I don't know if I'm off by 1, excuse me on the math. But yeah, so then now you're trying to query between these two numbers, right? Or these two ranges. And what does this mean? That means that you want to move this, the beginning, all the way to this bit. And then from this bit, from the perspective of this jump point, then now this is going to be 1 to 16. 1 to 8. Sorry, math sucks. 9 to 16, right? So it's 16 plus this, if you will, right? Either one of this. And then it just becomes binary search in that way. I know this is a little bit rushed, but this is just to kind of give you a taste. We'll go over the code real quick and you'll understand it. Or hopefully you'll do anyway. But that's basically what we're doing with the binary search. And also given this, we are keeping in mind that given n, we only do this, we divide it by 2 every time. So there's going to be log n moves. So that means that for each query, we only do log n operations. So this is going to be q log n, which is going to be fast enough. And that's all we want for this problem, right? Yeah, and then we'll go over the code real quick. So this is what I was saying. Actually, I think this is actually kind of wrong. It's not wrong. It's not precisely wrong, but it's not precise. But it's fine, right? Basically, what this does is that I sort it after making a copy. I sort it. I create a DP. It's not the perfect way of writing it, but yeah. And then this is DP of 0 is just by itself, and then this is after one move, right? So DP of 1 of X is equal to the max number X can get to after one jump, right? And more precisely, after one jump is after one jump. So then now, and then dp sub d of I is equal to the max number I can get to after 2 to the d minus 1 jump, right? That's basically it, because if d is equal to 2, then that's after 2 jumps. Yeah, I mean, that's basically it, right? And the way that you do it, I kind of wrote this, is by jumping twice, right? So here, for example, I mean, we already kind of visualized this. So if D is 3, so you're jumping 4 moves, then that means that you want to jump 2 moves twice, right? So you jump 2 moves, then 2 moves, so you get 4 moves. If you want to jump for 8, then you jump the previous thing, the lookup from 4 to 4. That's how you get 8, and that's how you create this sparse table. And yeah, sparse table here. Okay, the query is the part that, so this part, honestly, I got very quickly. Even the queries I got very quickly, but I was just wrong. And we'll go over why after this, but I'll go over this code, and if you're interested, I'll explain what was the issue and why I practiced, and that's, in the future, hopefully that should be good. But anyway, going over each query. Oh yeah, just to go over this complexity real quick, as we already said it though, it is going to be O of n log n time and space, right? And then now here for each query, we, if the U is equal to V, that means that they're the same node. So you just return 0, continue. Otherwise, here we want to go from A to B, left to right. So, so given the index U and V, we just map it to the number. Keep in mind that if they're the same, then this is just 1. I mean, I think this actually handles it now, but I just want to say, right, because they're not the same node, but if they're the same, not the same node, but the same number, they just make one move. That's it, right? Because there's only one case in which you return 0 move, and then you go from A to B, left to right. So if A is bigger than B, or if A is to the right of B, then we just swap them, right? This is the biggest case, right? So if we max jump and from A and still not reach B, then that means that this is impossible. That's basically what this means, right? So that's why we do -1 and then we skip. Otherwise, it is possible. So then now we go A, and then here we just go do the thing that we said about, right? So given D, given I is equal to we just truncate it to half, and yeah. So for example, if I is 5, so it's gonna be 2 to the 32. So then now you have like you're trying to go from 1 and 16 or 6 and 17 to 32. So then you check, right? From I, jumping 2 to the the other way around. Sorry. From current, jumping 2 to the I minus 1 moves, can we reach B? If that means that. If we can reach B, that means that we're able to keep on the left side. And by left side, just mean like the smallest part, right? Binary search, binary partitioning, whatever. So you take you keep the smaller side and you chuck away the right side. Otherwise, you keep the right side and you chuck away the left. But if we chuck away the right side, then we have to shift this by the halfway point, and that's this amount. And then otherwise, and also you have to make a jump to the midway point. We kind of talked about this, right? So we jump 16. In this case, 16 moves. We count the 16 moves, and then we just keep going, and that's it. And then we just do a total +1, right? So that's basically it. And this is log n ish. So this is gonna be O of Q log n time, and O of Q space, right? Because this is the Q space. And yeah, So okay, so what did I do wrong into not solving it? Because I got most of this in 90 minutes, or sorry, in 20 minutes, really. Um, Honestly, as a postmortem, and I talk about this at the end of the video as well, is that I just kind of rushed it. I thought, I mean, I kind of like knew the structure of how I want to write it just because I've written this enough times that I just kind of rushed it. And when I got it off by one, I didn't know how to handle it because I just thought that I was like a little bit off. But instead, it was actually my understanding that was off. And as a result, I was never going to get it without really digging into the binary search. And that's me being lazy, maybe a little bit tired, if that's an excuse. But either way, I just didn't do it. It took me a while, and if you watch the live portion, I spent a lot of times like jiggling it just to kind of try to get it to be not off by one because I just didn't understand what I was doing. But what happened was that instead of what I was saying is that okay, now we're trying to search from, let's just say 32, right? We search from 1 to 32. That means that our left side is going to be 1 to 16 and 17 to 32. And we just have to figure out which side. And this is easy because we know that we can jump by 16 moves. And if we jump by 16 moves, if it's on the left side, if we can reach the goal, we can reach B, then it's on the left side. If we cannot, then we just go to the right side, right? But what I was doing is that in my mind, and maybe this is just something that I'm too used to for whatever reason, right? I'm just a little bit, and I just didn't really think about it, to be honest, until the very end. And even when I thought about it at the very end, I came up with another way to solve it, which is not clean, but I'll show you just to show that as long as your understanding is right, you can solve it, even if your code is ridiculous. And my code was ridiculous. But my thing was that I was never going to get right, was that I was solving it from 0 to 32 as the answer. And what do I mean by that? I mean, this is a very subtle but huge difference, right? Because now we're going from 0 to 32, then now my binary search, and I was just not thinking through this, honestly, is that I was going from 0 to 16 and 7 to 32. But as you can see, these two are not perfect halves. And you could say that you don't need it, but as a result, what happened, and it was mostly right, and this is why this is off by one. But the reason is that when I went from 0 to 2, or maybe even 0 to 1, when I get to 0 to 1, I was trying to divide this into 0 to 1, and there's no second part. I just couldn't, like, I wasn't dividing the 0 to 1 into two pieces. So that's why I was wrong, and I was doing a couple of tricks to kind of fix this off by one without knowing that this was the off by one that I had, and I was just really wrong as a result. So how did I fix it? So initially I fixed it by converting this to 0 to 15 and 16 to 31, right? And this now makes it pretty reasonable, right? Because then now this goes from 0 to 7, 8 to 15 or whatever, 0 to 3, 4 to 8, yeah. And then more importantly, if you have like 0 to 2, it goes from 0 to 1 and 1 to, oh, sorry. Nope, this isn't right. If you go from, okay, let's just finish this. If you go from 0 to 3, you have 0 to 1 and 2 to 3, and then you have to go 0 to 1. Most importantly, you have this, and this is how you get right? Because now you're binary searching for one element and you'll get it. But before, I was doing it in one element. The hard part, of course, is that, well, the thing is that given how I structured it, now I cannot answer this query because I was just not careful. Because my jumps are by 8, right? Well, or by this amount and not this amount. And then now you try to kind of analyze it and go, okay, well, if we know how to jump by 16, well, what happens? If 16 is greater than or equal to B, well, that just means that 0 to 16 is correct, but it doesn't mean that but it just means that if you're given it 16 jumps, it means that 0 to 16 is in the range of what you want, but 0 to 16 straddles both these ranges, right? So this doesn't give you the answer. And this was also why I was struggling, because I was like, I was trying to figure out how to like use this to to bisect into this or this, but this includes both intervals, right? So that's basically the struggle that I had. And the way that I end up solving it is actually a mess. It's just that instead of this, I just query. So instead of querying for 16, I actually just query for 15. And then now if I query for 15, I just kind of do it that way. But the thing is that the way that I wrote it this way, if I jump for 15, I still jump to 16, right? Because if you, let's say you, this is good or this is no good, so you have to jump. You still jump to 16 because then now you to be able to answer 0 to 15, right? Because it's 16 plus 0 to 15 because now your queries are from 0 to 15. So the way that I end up doing it is that I just create a second jump table that basically gives me all the numbers. So here, if you have all the power, if you imagine all the powers to 2 is like 32, 16, 8, 4, 2, 1, 0. So then now I just also construct a jump table for 31, 15, 7, 3, 1, 0, and I guess it just doesn't exist. But yeah, and you can construct this actually by so to construct 31 is just 16 plus 15. 15 is just 7 plus 8, right? 7 is 3 plus 4, which in this problem just means that you jump 3 times and then jump 4 times, etc. So you can construct this recurrence actually not impossibly, but it took me too long to kind of debug and everything. And anyway, that's basically what I did. I have so this is, so you want to kind of, yeah, right? So you want to say, yeah, db sub I is kind of like after I jumps, or 2 to the I jumps, maybe I minus 1 jump actually, but yeah. Then in this case, dpp is you go to the max number of x can get to after 2 to the I minus 1 minus 1 jump, or maybe something like that. Maybe this is minus 2, but you get the idea of what I'm trying to do. I have an equivalent one, and I do this, and then as you can see, yeah, this is what we kind of talked about with respect to here, right? Which is kind of nuts that I did this. And then basically I solved everything here is the same. The only thing that's different is that now I look up the DPP, and then but I move with the DP, and I also added in a, you know, the indexes a little bit off just to kind of match the thing, but that's basically the idea. But the reason why I want to show you this solution is that yeah, because basically after a long time, honestly, I was able to realize that this is what I was doing, or that I was realizing that I was querying 16 or 0 to 16, if you will, and then once I was like, oh, how do I get it from 0 to 15 and 6 to 31? And I didn't know how to do it any other way other than construct a second DP that allowed me to do this jump, right? But once I did that, yeah, and then how did I, and the reason, yeah, but how I came up with this was honestly I just kind of looked at I look at Sheep's little Sheep's solution or whatever, and then I realized that, oh, he did it with total plus 1, and honestly it took me a while to understand what he was doing, but it just turns out that it just did it this way, right? Because now he assumes that everything's from 1 to 32, and then now he just searches from 1 to 16 and then 17 to 32, and as a result, then now everything will be, yeah, in that power, and then you just kind of keep track of 1 plus dot dot dot, and then with on the right side you just add 16, but then in this case it's 16 plus 1 over this, right, and so forth, and then dot dot dot, and that's basically how I kind of came up with it. But yeah, it's very yeah, I feel like I learned a bit, because I talked about this during the actual live portion, maybe as an excuse, is that I do not do this binary search enough, right? Yeah. Yeah. I do not write binary search in this way enough, and as a result, I didn't realize I thought I was off by 1 because I had silly indexing issues, and not that I had this entire issue with overlapping subsets and etc. And as a result, yeah. Anyway, to kind of that's why I have this one. Feel free to have questions Remember, have questions, not complaints. I say that because sometimes people are like, oh, I don't understand. That's not a question, that's a complaint. So yeah, okay. Yeah, so this is the sparse table, and this is the lookup with the query, and that's it, right? I'll also show you my other one where the sparse table, you can kind of look up the extra sparse table of this DP, which is, shows you that, you can solve it even if it's not the preferred way. And then here, you can kind of look at this and you can see that I have a lot of print statements because of a lot of debugging, right? Because I was still off by one, but afterwards a little bit better. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live during the contest now. Order, that's why. Okay, that is a dumb mistake. Hopefully that's it. Okay, that is a dumb mistake then. Alright, second hard. How am I doing anyway? I usually check up the 3 farms, see how hard the Q4 is, but yeah, that was pretty dumb. But I feel like I'm on par with a lot of the smart non-cheaters. Except for the wrong answer. Alright, given integer n, number of nodes. Oh, so this is the same as Q2 or something? Okay, what's the difference? Difference is it's not sorted. Okay, so that's why. Is it that hard though? I'm confused. Maybe. Oh, minimum distance, not a boolean. Okay, so that makes sense. I was like, it's the same idea if it isn't the thing, but in the distance part. Okay, distance part make it a little bit trickier. Huh. How do I want to think about this? Yeah, but some graph could be like this, where 0 can go to 4, right? I'm just talking to myself. So what does that mean? Okay, so the connected part is actually pretty straightforward. Then it's just about the distance part. Even the distance part is, oh sorry, we could sort this, right? So what happens when we sort? Then now it just becomes looking at indexes if they're connected, because that's the no, that's not the min though, that's the max. How do you get the min? Because that the index is not quite right. How do you get the min? Max is easy, min not so much. -1 I guess is for if it's not reached. Okay, so connectivity part is easy. How can it be 0? Is it the same node? Okay, fine. So there can be leapfrogs, right? So okay, let's say we sort, we leapfrog. How do you anything about the constraints? No, it's just 10 to the 5th. But just being 10 to the 5th could be interesting, maybe. We want to reduce the query down to log n. How can we do log n? You do log n with whatchamacallit. What's it called? Repeat double? No, it's not repeat double. What's it called? Yeah, I don't need to know the name, but it's just DP, right? What's the thing? And then it's just that number of components, almost like a sig tree. Okay, well. I mean, that sounds right, but it's annoying to implement, isn't it? Okay, do binary search. No, that doesn't make sense. But I mean, it is the same idea, but it's not that. Yeah, okay. I think I got it. It's just annoying to do. How much time do I have left? I have about an hour, 10 minutes. I don't think that I can do this in like 10 minutes as some of these people have, but I think it's fine. Okay. It's annoying, but fine. Right. Double think. You don't have time to update all those though. Maybe I'm wrong on this actually. I mean, I think the idea is roughly right, but I don't think the way I'm thinking about implementing is quite right. Yeah, I don't know that that's quite right. Because you can merge two parts perfectly to be right. Yeah, maybe not. Then what is the idea? Can I do some sort of sliding window? This is kind of, but not. How do you do jumps? Do I have to do the queries live? Oh, the number's unique. No, I guess they don't have to be. That makes it actually look annoying, but maybe, I don't know. Let me double check the definition. No, I think this is fine. So it doesn't, actually the numbers being non-unique doesn't matter. Right? Okay. Because then we get just updated queries to queries. Index don't matter. Max diff. Number of jumps. Number of minimum jumps. That doesn't make sense necessarily. Maybe I could take advantage of this. 10 to the 5th. Maybe that could be interesting. No, because that's not it's not the maximum number of frames. It's the minimum, right? How do you get the minimum? Even if you have all the okay, so let's say you have all the numbers compressed. How do you do it? How do you do it? Can I go up on the answer? Answers are most 10 to the 5th. Moves that 0 away. This is actually like an edge case. What to think about? Well, maybe not that, but two numbers where they have the same value but different places. So I cannot be. Okay, but let's just say ignoring that. And you can go to every other node. In fact, you only get yeah, let's say you build from that. Okay. That doesn't so we have like a almost like a hop list thing. Okay, so you always want to just get the maximum, right? So then you I see. So you can get the DP, but instead just get the maximum forward. And then everything that's in I see. Okay, so I did have this right idea, but I think I was implementing it well. I'm always really bad at this, though. Uh, 10 to the 5th is what? Yeah, let's just do it. 10 to the 5th is like what's 20? 20 should be fine, right? So that means that it's max photos away. Okay, and then you could just do it once because it's symmetry reasons. Okay. Yeah, okay, fine. Maybe we have to optimize for timing a little bit, but I think that's fine. It's just itself. Whatever, right? Nope. I mean, yes, but yeah. So you have this, and then you have this, right? Okay. It's not quite right, but okay, fine. Actually, just do this, and then 4. DP there. So okay, so 0 step away. Technically, it should be 1 step away, but that's fine. Okay, yeah. So is log n? No, log square n. Whoops, said it wrong, but I had my way. No, you just walk it once, because if it goes over, then you don't walk it. Yeah, I mean, it's almost like walking the thing. Okay. Yeah. Okay, fine. TPI minus 1 J. No, right? That doesn't you. There's no, I mean, you could put a max, but it's trivially just this, right? So you're just keeping all the skip stops, right? Does that make sense? Let's take a look real quick. It just doesn't make sense for what I'm doing, but what am I doing, Larry? What are you doing? What are you doing? This doesn't even take account the inputs. It is this, but you need to minus I or something weird. No, this isn't right. So, okay, so this should represent this, and so forth. No, I see, because I'm not tying that to reality, though that's not quite right anyway. Because it should be repeated doubled, so it's definitely wrong. So this should be these two. Man, I'm really bad at math. I mean, this should be these two, but not. This should not be just these three. This should be. What am I doing wrong? The idea is right, but I'm just struggling to put it together. This should be the answer for the first four, which we can do by sliding window anyway. But yeah, I mean that's fine. But that's just it's awkward, but fine, I think. What do I want? Okay, think before you program. In one move. Okay, you have to pre-calculate the one move. That's easy, that's just one binary search. And then yeah, I can see why I figured out so quickly, but I'm not one of those people. Okay, so you have this, that's fine. Okay, let's erase this for now. Also, just yeah. Let's just do this for now. I'm too tired to think. And then now DP. Nope. is equal to, okay, so this is the base case. You can probably define the base case with 0. This is the base case. We want to array bisect left array sub I, right? That gives us the index. And then array sub index dp sub I 0 sub I plus array sub I. Let's just say none for now, actually. And it shouldn't matter anyway. The way I'm doing it is a little bit awkward, but maybe it's fine. Times m. M plus 1 by definition. Okay. This isn't even right, but why would it give me array out bounds? Oh, I. This is n. Okay. So of course it should be just itself because I didn't. So it should be the small. So it should be plus. So it should be bisect right plus max diff minus 1, and then this should give an error on some of them. Oh no. Okay. 1's biggest number is 4, 2, 3, 4. So in one operation you could go to 4. Maybe not itself. Maybe I should not count itself. But it's fine. So, well, in one operation you can definitely get to itself. So maybe it's fine. Okay. So then now how do I do the merging step for the thing? Yeah, okay. So then now for d, small d is range of d, dp of d okay, right. So then now for I in range of m plus 1, so then you have dp of d minus 1I. So this gives us the max, the previous max. So then now you want to do it that way, right? So okay, so let's just say next is equal to this, and then dp of d sub I is equal to dp of d minus 1 next, something like that. It feels a little off, but I think the idea may be right. Oh, this may be none because of the way that we did it. No, that shouldn't be true. Oh, I mean, that shouldn't be true, but it is true. Oh, because it is just none itself, right? So, okay, so dp of d minus 1I is not none. Okay, so then now it does. Is this right or is this okay? I mean, I think the idea is roughly right, but I don't know if I'm doubling, which is actually not great. Alright, let's see. Okay, so one move is going to be all this, okay? This is 2 moves, which is true. But then I want 4 moves. Okay, so this is good. Yes, okay, this is good because we want 4 moves here, right? So then now Now we're able to get the answer, kind of, maybe. We will see. Right, so for UV in queries, if U is equal to V, then we just return answer, or return 0. That's the only case where it could be 0. Otherwise, we have to do the binary search walk thing, which I'm always a little bit weaker at. But we're almost done. How much time do we have left? 51 minutes. So we should be able to do this in 51 minutes, if slowly and deliberately, right? So okay. Yeah, okay, yeah. Because I don't usually write the binary search this way, but I think a lot of people do, and that's why. But that's fine, I think. So, and I need to be better about it maybe, but yeah. Okay, so we want to do D -1, -1, -1, right? So then, okay, so current is equal to, oh, I have to get the symmetry things. Yeah, okay, so we want to get from, okay, so U and V, right? So num sub U, num sub V, we just go from, let's convert it. I'm too lazy to, we use the variables. Maybe that's a bad idea actually. I find it just called AB. It's the same idea anyway. Okay, so we're trying to go from A to B, right? So if A is greater than B, B is equal to BA. So we swap, and then now we're trying to go from A to B, right? So then now, how do we do it? If dp of j of A, if this is greater than, if it's strictly greater than, then we don't want to take it, right? It's a little bit awkward because I think it could be off by 1, but this binary search is a little bit awkward, but it should be fine. I just had to figure out. So okay, if this is greater than B, then we want the idea of taking it, but we don't have to. So that's why this is a little bit awkward. Okay, no. That's the reason why this is awkward is, okay. Yeah, okay. We just have to check. So this is if dp of d minus 1, A is less than B, then we cannot, it's not possible. We return and then we continue. I also need to continue on the other one, but I forgot. Okay, and then now that means that it is possible, right? So then now, if it's possible, then we just start at d minus 2. And then now, if this is possible, if this is not possible, then we have to take the j plus 1, right? So, okay, total is equal to 0 maybe, and then total 1 to the j plus 1. Yeah. Right. So that means that we took the previous one, and is that true? No, I mean, it's kind of true, but you have to. The walk is a little bit trickier because then now you walk that there, and then now you walk the subtraction, which is the weird math. Maybe I'm setting this up a little bit incorrectly because I'm not used to it. The idea should be right, but I'm not setting it up right. Because, okay, so if it goes over, that means that it's fine. Right? Okay, let's rethink this, right? we go, okay, we ask, I think I'm just trying to be too clever. Let's actually do it with the way that you know how with binary search, right? So okay, so left is equal to 0, right is equal to J or D minus 1 maybe. And then the idea here is okay, so you have the search space, you want to go okay, and you know that it's possible, so you want to ask if it's in the first half or not, right? So okay, maybe that's how I should have done. There's like a fruit fly flying around. It's annoying me, but okay. So that means that let's just write it without the loop first, right? If D, that means that now we are. So it is possible. Okay, so we have the entire search space of these, and then we go, okay, well, is it in the first half or the second half, right? That's kind of what I was trying to write, I think, but it's not A, that's why. It's, okay, so current is equal to A. Let's see if this is in the first half. Why do I don't even have food in my apartment, I don't think, unless I messed up. Why is it going on? Maybe just the weather finally being nice. Okay, so if this, okay, if this is in the first half, then that means that this is the case. If this is the case, what does that mean? That means that it is in the first half, and then we could just continue. Otherwise, which is kind of what I meant, we want to update the second half, and the second half will require that many number of moves. So then total, something like that, right? I wrote it awkwardly, but I think that's right. Ish. Maybe it's off by 1, but I think the idea is right. So let's see. Okay, I mean, that's definitely really wrong. I mean, this is really big, but okay, let's take a look at the other ones real quick. And this one I think is just, oh no, this isn't right. I just kind of got lazy with the query. That should be something like 4 or something. Okay, that's definitely not right. 0, 0, what? What are you doing? What are you smoking? Okay, everything is wrong. But how much time do I have? 40 minutes. Okay. So it should be 1, 1. We have 0, something big. Okay, why is that? So if it's in the second half, we move it to the second half and we take that number of moves, right? How is that not right? Whew. Okay. I current B, maybe. So we'll just do a delimiter so I could tell. Definitely rusty. Like I feel like I know this one, but yeah. So we want to go to 0 to 3 doesn't make sense, right? Oh no, not UV. It's AP. We want AP. Right. So we want 1 and 4. which is one move, 18, current B, so 0. TPI current. It's 4, meaning that it's in the first half. Oh, I see. So that means that it is within one move, it's Y. But I guess that is awkward. Maybe I should have done it. Yeah, maybe I do need one more layer. Like this is fine, but I think I want one more layer of. Okay. I mean, that was just going to be impossible. Because this should be for 2, right? Okay, I'm still getting the wrong answer because it should just be 1. Okay, so this is 1, so that means that it should. So it does this part, right? Or it should do that part, right? No, it doesn't for some reason. Maybe I need to start this off this here. I don't think that matters though for this one. Why is it not triggering? This is clearly. Oh, it's less than my condition is wrong. If this is, oh man, I'm just dumb then. Okay, maybe that's fine then. Oh, okay. So it is just because I'm dumb. I mean, this one is wrong, but I think it's because maybe some of the ways that I was correcting it was wrong. So let's remove this. Let's fix this. I think everything else is okay maybe. Where is it doing none type 45? I may not be throwing it out correctly again. Okay. Okay. I mean, this is all wrong, but maybe that's fine ish. In one move you can do this. How do I get this to trigger? Now everything is over. It's saying that in one move you could do it. So then now it's trying to do in 0 moves. Oh, I don't do 0 moves, so that's why. Maybe I do need the thing. Yeah, okay, fine. Maybe that is a little bit cleaner. Okay. So now 2 of the first one is right, the second one is way wrong, the third and the last is, well, the second is wrong and the last one is wrong. Okay, why? It's trying to go from 1 to 15, is that right? It should be 1 to 16, right? Oh no, it is 1 to 16. 16 is here. So then now we have current is weird. Why is current 15 already? Huh? Current is A. Huh? Taking too much time, even though I think I have the general idea. Okay, so 116. Okay. Left side, left side, left side, left side. Okay, and then now it goes. Am I saying it right? Why is this adding so much though? That's the thing I'm trying to figure out. Like here, it's saying that it's on the right side. On 3. Oh, wait, maybe I just forgot 2. But it still seems a little bit high. That's the part that I forgot to do, but maybe. Negative shift? I think this doesn't go. I don't know. This is, I think the idea is right, but I'm having very awkward time with this for sure. Okay, let's go through it real quick. Why does this take 16 moves? Because this is a 3. Because, okay, it's saying that it's on the right side, and if it's on the right side, that means that we want to go from 0 to 9 in one of the moves. I mean, I think this is right, but I don't know why this would be negative. I think that's probably the wrong part. Because it's saying that it's on the right side. If I is equal to 0. If I is equal to 0, something else is wrong. Maybe I won't finish it. Maybe I'll just end up spending all this time here. Okay. Did I do this wrong? So that means that on this side, did I do this one wrong? If the furthest is to the left, and this is impossible, okay. So if this is, if it's on the left, if it's on the left. No, that means because if it's equal to, you want to add this. Okay, I think that's partially why. Don't know why it's giving me all these numbers though. No, I guess not. I guess this is wrong. If the left side, okay, yeah, if the left side is to it, we don't have to make any moves. This is right, I think, but I don't know why this is giving me. Even when you know it, you don't know it. Why is this giving me 8 moves? And why is this giving me 0 moves on the top? Okay, so here on 0 index, it has to make 1 move, right? Okay, fine. I don't know anymore. Okay, so let's do 1 move. Oops. I think that this is fine, but then I don't know why everything else is wrong. Okay, what is the second query? We're going from 0 to 2. There's no possible 3 anyway, but from 0 to 2. 0 to 2, so 1 to 5. Widest thing is 3, so it's 1 to 5. So this one, maybe it's related. And it goes to 0. Okay, so in 1 move, it only goes to 3, so then now it goes from 3 to 5. 3 to 5 should take 1 move, that's true. But in 1 to 3 should only also take 1 move, right? Oh, I see. Because it should take one move, but we are adding two moves. That doesn't make sense though, right? Am I doing the DP wrong? Maybe my DP is wrong. Let's check the DP. Okay, so it's here. 1, 3, 5, and then this is no moves. One move, it goes to 3, yeah. Two moves, it goes to 5. I see. It thinks that it's on the left side, so then it thinks that, okay, so if two moves, it goes to, if it's exact, I'm doing this a little bit off. I think this is, my condition is wrong a little bit. Like people who are very good at binary search know this one, but I struggle with this because I don't do it this way. Okay, so if it's exactly B, I want to write something like this, but it's okay. It's okay. So it's this. Okay, so if it's on the right side, what does that mean? Is it, am I actually messing this up? It should be this. Basically, it should be adding 2 instead of 1, and then another. Oh no, well, this is saying it's 2. It should be I minus 1. I plus 1. Okay, so what does it mean by being middle? Okay, so I think my thing is wrong, right? So I think my condition is wrong. So the left side and the right side, what does it mean by the left side? Left side means that if it goes there, then it is on the left side, but the left side is not. Oh, you don't shift it correctly. What you should be saying is there should be an I minus 1 somewhere. That's why I think that's it. Okay. Something like this. Oh, now we're talking a little bit closer. It's still wrong. Oh no, it's right. This one is wrong, but oh wait, no, that's right. Right, I forgot that I made the jump 1. I am a dumb boy. So this is right, I think, maybe. All right, let's YOLO submit it. I don't have that much time anyway. I mean, I do have a good amount of time actually. 28 minutes, but I'm just ready to YOLO submit and then see what happens. If it times out, I'll also be sad, but if it times out, it would be really weird actually, to be frank. I mean, this I don't know. Oh no, I mean, just a 0 to 1 answer which I don't handle correctly. I'll put 0, expect 1. Oh no, this is 0. Oh no, I see. Yeah. I actually was thinking about this case, but I forgot about it. If A is equal to B, U is not equal to V. So then, and I did think about this case, but I thought it gets handled, but I just forgot to put it back in. Or like I forgot to check for it. Like I thought maybe this handles it implicitly, but I just forgot to check for it because it took so long trying to debug this. How much time do I have left? 27 minutes. Oof, that's a tough one. I thought I'd be very close to done, and okay, so this is 4. I expect 3. Right, 1, 2, 3. 1, 2, 3. Yeah, I mean, there's no way it should be 4, unless I did the math wrong. Okay, let's look at the DP array. This is very weird, actually. Okay, so 0, 8. It makes, oh, 0 is an input. Okay, oh, actually. So 1 move is 8. 2 moves is 14. 4 move is 18. Okay, so then it tries to do 2 then, right? Or should? Am I? Okay, so it tries to do 14 and then 8, so that should be 3 if I'm doing it right. But okay, I mean, I guess we just have to debug it. I don't know. It is what it is. It goes from 0 to 18, right? So the last thing, 0 to 18. Okay. Ooh. Am I doing this one? So it's 18. So it thinks that in 4 moves it could get to 18, which is true, right? Oh. That's awkward. Am I? Maybe well, I think my binary search is just bad, to be frank. But yeah, maybe I don't know how to do it, and that I need more practice, because it should go from 4 to 2. Okay, 4 it could do it, and then 2 it cannot do it. So it adds to 2. Why? Actually, why? So it goes to 14, so then it has to be the right side. But it actually wants... Did I set this wrong? Maybe I set this wrong. Maybe this should be this, actually. Maybe I was just wrong. Nope. That doesn't feel right though, right? Why would you jump to... Okay, so it's 14, so then now that means that you have to go to half of that. Because that's the number of moves you make though. Why would it jump to 18? I mean, this kind of makes sense, but then now you... Something doesn't make sense. Because why would you jump? Because then now you jumped, but actually you want to go. You do want to go to 14. That's the hard part. But and not 18. It doesn't really make. You can't really go to. Well, you can go to 18 if you take the 4, but if you take the 14, you want to take the 14. Do you? Is that always good? No, I think that's true, that it should be always good. You can't go any more anyway. Okay, so you always want to take the 14, but the number of moves is wrong, right? Because it's saying that, oh no, this is saying that if you take 4 moves, something is wrong. If you take 4 moves, you can get to 18. Because if you take 2 moves, you can only get to 14. So, but you know that by definition, so it's between 2 and 4. The answer is between 2 and 4, not that you add 4. So something is really off here. Like, I almost want to write this, but it just, that feels even more weird now, right? Yeah, I mean, now this is at like it should go to 14 and then that's fine, but then now you have to do one more. But I don't know how to do it. I'm like off by one somewhere. I'm just not good at this. Almost quit submit by accident. That would have been not fun. Okay, so how do I correct this binary search? Okay, so what are we doing? So we're saying that the left side is going to be equal to A, and oh no, the left side is going to be 0. Right? Okay, what are we binary searching for? We're binary searching for this section. So left side is going to be the number of moves. So it's going to be 0, and then the right side is going to be, say, I guess the most, which is d minus 1 or 2 to the d minus 1, right? Yeah. And then now here, I think there's a subtraction somewhere, that's why. But I'm just so not practiced on this, clearly. Okay, right. So we take the left side. So this is the left side. Then now right is equal. We subtracted by right? Here, then left. I don't know, does that even work? In total it's just gonna be 0, but 4 and 6, what does that mean? And we update this so it's a little bit awkward. It's not good enough for this. I'm not practiced enough in doing it this way, even though I know the idea behind it. Okay, right. Without adding another layer. What if I just do this? And you just have a lot of big negative numbers, is that right? Yeah. Okay, so the idea here is that I think here, because if it's equal to, okay, can I redefine this? If it's equal to, then that means that left is possible, so we just continue. Otherwise, if it's equal to, then we actually don't do this. If it's equal, now we want something like this. That doesn't make sense. If it's equal, if it's on the left side, then we definitely want to go to the left, right? Yeah. Then now, if it's no longer true, now we know that here we can't. The left doesn't hold anymore. And what does that mean? But it still means that it could be on the well. In fact, it has to mean that it is on the right side. So that means that it's like this. I'm not used to writing binary search like this. And at this point, I'm struggling for so long. Can I change the form so that it's easier for me to do? Let's see. We know that that means that we know this is the maximum number of moves, right? So then now okay, so if it's equal to, it's on the left side. But what does it mean for it to be on the right side? So this is saying that can only go from 0 to 14 and this doesn't make sense. I think I'm just off by something. Because this should not be 4 moves to go to 18. No, the left side is right. But this is actually, I feel like this is wrong. Like we should just go to here because we know that well now it takes 2 more, but why is the other thing 0? But this doesn't make sense that we moved that much for this move, so I think something is wrong here. I think this is more right in either case. But, well, no, because this is, because it takes 2 moves to go to 14 on this one. No, this is more correct. No, I think this is fine, but am I checking the wrong thing? Okay. But why would you go to 18? We skip it. Oh no, because it's not possible. But the answer is not to move all the way to the right. It is to go halfway there, right? And I'm not doing the halfway part right. This is where the halfway part is more sensible, but then like now I want to write this, but then now everything just, it's like everything's just shifted. So yeah, because then now this is 14 here. I'm writing this really poorly. It's almost like it should be this plus 1 in the number of moves, or it's this, but you want to add 1 more move, right? So dp of 0 of this, oh, one move. To get to the next. I don't know. I feel like I'm so close. I knew the ideas, but I'm just so bad at this part of reconstructing. Yeah, another loop of 20 would be too slow, I think. Yeah, 20 times 20 is 400. Yeah, that would be too slow, probably. So this is the number of moves. So we're binary searching on the number of moves. So this is wrong. It should not be. This is definitely wrong. But then now this is just everything off shift by 1, and we have the wrong answer that we had for before. Okay, so taking this is the this is more roughly right, but where this is just saying that okay, if it 2 is 4 moves, if it takes 4 moves, it can get there. Why is this 3 6? Maybe this is wrong. So okay, let's take a look at DPs here, right? Am I just confused? Okay, so 0 move, 1 move, 2 move is 14. It is I minus 1. I think this is right. I think the math is just this is right. So okay, so 2 is 14, but we want 3. So okay, so if this is 14, then this is that B is too small. We add. So for I is equal to 3, we take a look at 2. That's 2 moves, right? So I think there's something weird with my math. We want to take 2 moves and then go to I minus 1. Right? But then now we don't add the last move. And also, I don't know. I just feel like... Yeah, fine. How do I do one more move, right? One move will be I is equal to 2, right? 2, it just checks, 2, you check, right? It should be here. It's just that now this is good, so we don't need a move anymore. This thing is wrong. This is saying this is not the left side, right? So you have 1 move. So if I is equal to 1, now if I is equal to 2, then in 1 move it is able to do it. That's not the left side because it's 0 1. Okay, so that's why my binary search is so bad. I mean, maybe I won't finish. It's fine. Let me take a screenshot. But that means that if I is equal to 2, then it's saying that okay, in 1 move I'm partitioning the space incorrectly because now it's no longer asking for 0 and 1. It's a space of is it this? Am I just being dumb? No, maybe. I just keep shifting it, but in one move, but it's not even the one move zero. Okay, everything the setup is right, but the binary search is just wrong because now we made two moves, but then now the recursion should be 0 and whatever, right? Maybe I need to be a little bit dumber. This is just try to. I mean, this is really ugly, but maybe that's fine. Current. No. Okay, so if it's not, I think the bounds is weird. That's why. Okay, because if this is the left side, okay, so there's 4 moves. If I is make it so that's 4, then we want to try check 0, 1, 2, and that's why. Because I'm supposed to check 0, 1, and then 2, 3 differently. That's why my binary search is off. So actually, okay, so if it's left side, and it is not this. If it's the right side, okay, so if it's we have 4, if it's wrong, no, if it's 4, then we actually check for 2 and 3, not 3 and we do not check for the 2. It's 2 minus 1 because of the 0 space. I see. I really had to get back to principle. 4 minutes. No, the way that I could do this is fine. If it's 2, we add it by the number that we 2, right? And then now it's instead of searching for 0. Oh, but you have to be able to search for 0, so you can't do one index. That's why. So instead of okay, so that means that if I see, how do I check for I minus 1? I have to do one previous move. That's why. Wow, I do not know how to do this at all. Okay. How do you do minus 1 move? I mean, we just have to pre-cache it, I guess. Pre-calculate it. So here is 2 plus 1. Eh. There's no easy way for me to do one move backwards, is there? And definitely not in 3 minutes. Okay. I see. My binary search is really off. I didn't really go back to first principles. We'll figure this out, just not within contest time. And it is what it is. Okay. So 1 is fine. Okay, and then now so we have this, but not really. It is 1 previous to that. So then okay, so this is 1 move, so this is 0 moves. And then now, so if it's 2, it's going to be 1. So it's just so this is whatever, but what we want is something like this, and then this, right? To go backwards 1 step. I don't know if this is right. But then now, it's something like this. I think this should be 15, 15 should be right actually. I don't know. Alright, we just finished the contest. The timer just went out, so this is YOLO time. It's still very close, but not close enough. Oh, I like that they don't reset me anymore, which is nice. Oh, and then now they tell you the thing. But I mean, I was going to submit it anyway, so. Okay, I mean, I don't know how I feel about it, but let's see, how many, I mean, we're very close, but I guess we're just off by 1 or something. But the binary, I mean, this one was a little bit more YOLO because I was just like, I have no time, right? But let's see. So it's 6 to 7, which is 0, 1, 2, 3, 4, 5, 6, 7, so 28 to 193. So it's 28, 81, and then I don't know, 119 and 119. What is the answer? Wait, let's see. So it is 28 to 81 to 157, maybe? Is that it? No. It has to be 119. And then 193, maybe? 64? No. Am I doing the right 0, 1, 2, 3, 3, 4, 5, 6, 7? Yes. Right? Yeah, okay. It thinks the answer, oh no, my answer is 3, but it should be 4. Okay, so 4 is right. Okay, that's what I thought, but I was just so confused because this doesn't make sense. Okay, I always do that actually. So this is the right answer, but I guess I do 3 for some reason. I mean, I kind of rushed this because again, my DP is wrong. I think this DP is wrong. It should be, no, I think, yeah, I think it should be this way, actually. I kind of rushed it. It's still the wrong answer, so maybe not. Okay, so basically this is because we want to check 1. Yeah, okay, this actually, no, this makes more sense. It's wrong, but it makes more sense. Maybe now we don't do it this way. Maybe here, I was just, maybe I was overcompensating for, that's what I was overcompensating for maybe. But and then now, okay, now this is just way wrong. Huh, why is this so much wrong? It's because of this. Okay, but it's still wrong. Alright, let's just print out. I got DP. I think I could have figured it out, but oh, this is kind of awkward to read. Maybe I could also optimize this to be a little bit faster, for sure. Doesn't have to be an array, does it? Actually, I don't know that I made it array specific, so maybe this is fine. Key error. Oh, well, yeah, wait, where? Line 19. Oh. D minus 1 in. Wait, which one? Oh, I. It's probably I. I probably could clean this up as well, but I just wanted to see. Okay, right. I put it. Okay, so 28 goes to 28. 2 steps. It goes to 81. 4 steps. No. This is 0 steps. This is 1 step. This is 2 steps, which seems right? And then this is 4 steps. So 4 steps is definitely right. But okay, so the D. Oh yeah, this part I actually okay. This part I could see why I'm wrong, or possibly I'm wrong, because I didn't really think about it that much. So this gives me a number from and then do it dp minus 1. I feel like this should be right, but maybe I'm wrong here. Okay, so 1 step, 3 step is 81. Is that right? Maybe I'm. Oh no, maybe this is. Maybe I'm off by 1 in indexing here. Maybe that's why. Yeah, maybe that's why. That doesn't make sense. Okay, maybe that's a little bit better. Okay, it is still wrong in this exact same way, which I guess is consistent, but at least it gets shipped a little bit. Yeah, this should not be bigger than this, so that's definitely wrong. Because this should be 0 steps, maybe. Should I have a 0 step? I don't know how I feel about that, but okay. 0 step, maybe that's why though. This should be 2 to the I minus 1, so this is actually wrong. So maybe this should be a 1 actually. Maybe that's fine. So maybe I just did it anyway, but okay, so it's still wrong, but okay, so 0 steps. This should be 1 step. This should be 3 steps, but 1. So this is 0, this is 1, this is 2. But I guess going from 1 to 3 is an awkward thing. Right, so this is 3. So 3 already goes. Okay, so what am I what am I saying? So it's going, okay, let's say there are, so we're trying to see if 8 moves is enough, but we try to check whether 0 to I think I'm just like really off by some, well, just off by 1 in a really bad dumb way, because we're not partitioning the space correctly. Because we're trying to accept 0, so I think the math is here is just off. Because when you shift, you shouldn't shift. No, I think that's fine. Is it? Yeah, if you jump, it's fine. But I think this part is wrong. And actually, we could find this one's cleaner with the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it's 1. So that's 0. That's yeah, that's 0 steps. That's 1 step, and then next one should be 3, and this is 5, which is actually wrong. So maybe that's partly why this is wrong. It jumps too much. This is 1 step. Going to 5 means that it is 4 steps, not 3 steps, right? So why? The why is because we want to do 1 step plus 2 steps. Because we want to do 3 steps, and so that's 2 to the 4. That is weird actually. That should be a 4, because this is a 1 to the 2 and then 2 to the 4. I think maybe order shouldn't matter though. Maybe it does. But in that case, that would be wild. I don't think it should matter. No, it shouldn't matter, I don't think. So if my indexing is wrong. Why is this indexing wrong? Okay, at least now we know why. It should be 1, 4, 2, 4, going 3 steps instead of 4 steps. Okay, so that means that. Oh, that's because I used next instead of I am dumb. Okay. Okay. I think now we're better. I mean, we're 2 times everything, which is, I don't know if it's, well, we're doing a lot more. But maybe now we can finally fix this part. Is this it? Right, let's take a look real quick. Why are we doing so? Oh, maybe the adding is weird. Maybe now this is what we're doing. Okay. I mean, it's so annoying. Well, the add thing doesn't make sense, I suppose. Because this should be... So if it's not from 0 to 3 in the left side, then it'll be on the right side, right? Okay, wait, what does it mean to be on the right side? Maybe I'm just doing it in a dumb way. If it's on the right side... No, oh yeah, that's why. Because we want to ask whether this is this, right? So if this is B, that means that on the left side, the biggest on the left side is not possible. So we have to go to the right side. And this is now going to the right side by updating the current and then adding the number of moves, which is, I think, a little bit off. But is this right? Or at least, I don't know if it's right, but there's no difference. That's what I tried to do, but I was just sloppy. I think one thing, and this might still be wrong anyway, but I think one thing that I was doing is that I was trying to do too much magic and not try to solve the problem. Or try to resolve it with, okay, time limit is good. It means that, I don't know, I mean, well, we'll see whether that is like a real time limit or, yeah, I mean, it's good in the sense that it means that we are mostly right. Well, why is this so slow then? It means that we're mostly good. I mean, here, it probably just means that we should not do this loop, because that's just dumb. It should be for, I mean, I said that I would look into it, but then I just forgot. But, anyway. Yeah, now it's much faster. But then I just forgot. But I mean, because I was focusing on getting it correct versus, yeah, okay. I'm a little bit sad, honestly, because I don't know that I've gotten it in time anyway. But I think I was trying too much to cheese it. And what I mean by that is that, like, I was trying to rely on my experience versus rebuilding the knowledge needed for this one, right? Like, I was like, okay. Until I had no choice, right? When I had no choice, I really did finally do it, but and maybe some of it is just my setup is a little bit wrong, but yeah, when I had no choice, I really had to dig deep, but I should have dug deeper to begin with, because even then I knew that I wasn't like knowledgeable about it, right? Like I was like, this is something that I know I'm weak at, but yet I still try and like YOLO it into submission. But that was not quite the way that I should have done it. But yeah, I mean, I don't know. It is what it is. What is the running time for this now that I fixed that? I thought that would be fast enough though, actually, even with this, but maybe it just does too much processing work, I don't know. Want to take a look at the running time. 3 seconds. That's a lot of savings. I didn't expect that. How long are we from? So we're like about 10 minutes more. Wait, I guess I could look at my. Yeah, I think we're like 20 minutes out of it. So I don't know. I feel like we're okay. I probably could have done a little bit better. Let's see if I could learn a little bit. Let's not learn from ChatGPT. I know this person ish. I know of this. So yeah, I mean, this is basically the same idea that I have. Oh, this is smart actually. Maybe. That's what I was doing here, right? Oh yeah, no, this is what I'm doing here. How did I get the off by one part? I mean, that's the part that I struggle with, right? Like I had this most of the way. I guess this part maybe. And stop. I guess the way that I set it up, I was just off by 1 for like an hour. Or rest plus 1 by an hour. Could I have done it? I mean, I am going to spend a little bit extra time because I feel like this is something that I knew I was weak at, and I kind of had to do crazy things to make up for this off by 1. And I wasn't sure that I could have done it this way. That's why. I mean, I think everything else I was very similar. Right? So Yeah, I don't. I guess I didn't need to binary search. That's a little ridiculous. It is literally if we sort it, then it'll be the next index. But whatever. Um, Okay, let's say we didn't have this, which is what happened. What people did. So I had the 0 case, the 1 case, the -1 case. Do they have the 1 case? They don't have the 1 case. Wait, just this. Wait, I did do the step correctly. So step is if dp. Well, they do it by I, but I do it by I. I'm trying to understand this a little bit because this is the type of dynamic programming that I know I'm really bad at. So it's something like this thing, right? This is clearly way off. I mean, this is fine. I don't care about that. I mean, this is built, okay. So, and 0 is just all zeros. And then, oh, he does it by index. I guess that's why. Is that true, Larry? I don't know. I maybe I need to step back and think about this at some point. Not now. Well, the idea should be roughly the same. Yeah, I don't know why. Well, no, I mean, excuse me. What is left? Left is just I. Oh, yeah, I see. That's just to check whether they're the same initial index. Which is kind of weird, but okay, that's fine. I mean, I had the same frame, so I had the ideas, but I just couldn't do it. But why couldn't I do it? Well, I'm off by 1. Not that I'm off by 1. I'm just here. We're differing by 1 for sure, right? So here, he set dp. So he just sets all these to 0 for whatever reason. Also, I think if there were arrays, we would have been fast enough. But okay, so for whatever reason, he set them to 0. Here, same idea though. Yeah, I mean, this is literally exactly the same. Oh wait, no, this is a lie. Previous, right? So previous. Actually, I don't know what previous means. Previous is all zeros. Oh, it's just the last element. Well, nums of I. I mean, he walks backwards. I think that's what he does. But it's the same idea. Because he gets the... Yeah, he gets the U to be the bigger number, so and then he walks backwards. So the idea is still the same. And why am I? Oh, I guess this condition is not going to be the same if he's walking backwards while I'm walking forward. Huh. Maybe. I don't know. I'm not going to fix it down. Oh, this part probably there's some awkward thing, but I think the idea is roughly the same. But I don't know why that I had to do also. Okay, I'm going to see if I could yeah. So this is closer in spirit, right? We just set up the DPs. This jumps to the next one. Okay, right. 2. But I don't know why I had to do the thing that I did because I was here really early, but then I don't know why I'm not fixing it. Okay, so maybe the left side. No, we want this if only it's on the right side, right? So if B is, then we want it to go on the right side. Is this it? Give it a quick submit. Why was I so weird then? I had to do some crazy things, but I was just off by 1. Alright, let me think about this real quick. I thought I had to do what I did, but I had most of this. I just had some weird off by 1s. Right? That I had to readjust. Oh, well, because I didn't do the total plus 1. But I wasn't confident. I did remember seeing something like this, but then I wasn't confident. Well, because I don't have all the expected engines in run me either, right? So I wasn't sure that total plus 1 would have done it. Why is it total plus 1 enough? Huh. I mean, I guess, yeah. I think it's just me not understanding this way of doing dynamic programming, which I knew that. But the total plus 1 really made it faster, huh? I have to understand why the total plus 1 works, I suppose. Excuse me. I mean, it's still just binary search, but I don't know why I wasn't able to do it. And the sad thing is, I was debugging this for like an hour. So, I mean, on one hand, I feel like I'm okay with like I knew how to do it clearly, ish, but I wasn't able to kind of finish the last part. I'm not sure. There's a very awkward way of writing this as well. So maybe this should have been just I think that part would have made sense. Somehow this is. Oh wait, no, that's where speculation. Yeah, I mean, I had most of this, but I'm really sad that like because I would have gotten. I had. I mean, I don't remember the timing, so maybe I should just check it. But like I had most of this. I knew how to do it, but the total plus 1 thing bugs me a little bit. I mean, I'll think about this offline, friends. But I think for me, I think that's the part that I was a little bit confused about. Like, why would it be? Okay, so we always assume 1 move. But I thought that's because we do this maybe. And this is the 0 move. Can we remove this level then? I mean, technically yes, but then we have to update the costs. This should be I now. But why didn't I think of the total +1 though? Oh, this is also still wrong. I don't know anymore. Let's put it back to the good state. Oh, because now the +1 is not factored in. Okay, fine. But wait, why is this? Oh, why is this now not working again? See, I can't even tell why this is wrong versus the one that's right. So that's why, like, it doesn't feel like I'm understanding it when that's the case, right? Oh, I guess we don't need this if statement anymore, but I mean that shouldn't have changed the answer. I was just saying. Oh, I know why, but I don't get why. Am I just missing something about the total +1? Oh, let's give a quick submit just to make sure that I'm still okay. But yeah, I guess that is one of those things where, you know, when you're out of practice. I have to think about this offline. But yeah, that is all I have for this one. Let me know what you think about this contest. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye. Yeah, so as soon as I stopped recording, I've realized what I was doing wrong, and it was kind of the same thing that I knew what I was doing wrong, kind of, and tried to fix it, and that's why I fixed it in that very confusing, convoluted way. But the TLDR was that I was searching for a space, right? The thing that I was binary searching was that I was binary searching in a very natural way, or at least natural to me, because that's the way that I've been practicing. I just haven't really thought about writing it in this way in a long time. But basically in a normal binary search, maybe I would have to, like, let's say our search space is 0 to 15, right? And for this particular way of writing binary search, it is kind of important that everything is a power of 2, kind of. But the reason why I say that is because when you do from 0 to 15, then now you have 2 equal parts where you have 0 to 7 and then 8 to 15, right? That's the part. And here in the binary search, you're trying to get 2 sections. You're trying to go, okay, is the answer in 0 to 7 or 8 to 15? The problem is that the way that I constructed the problem, I only am able to do queries at 8. But the query that I'm able to do at 8 does not give me the answer of whether it is on the right side or not, right? Because the query we want to do at 8 is whether after taking 8 steps, what is the furthest that we can go? But if it goes past it, it doesn't tell me enough because it could be exactly 8, right? So that's basically the troubling thing about this particular part, and that's the part that I didn't figure out. And the total +1 part is just that it's converting instead of 0 to 15, we're searching from 1 to 16, right? And now searching from 1 to 16, we're now searching from 1 to 8 and 9 to 16. And of course, we assume that it is 1, so that's where the total +1 comes in. But also now, because we have 8, we can check whether it is on the left side because we have the number 8, right? So if it's on the left side, then we are able to check, whether after 8 steps, can we go far enough? If we can go far enough, then it's on the left side. If it's not, then we have to go to the right side, and then we do the following up things. I'll talk about it more in the explanation, but that's basically the idea. And the reason why I was struggling so much is this idea that I was going from, say, 0. I wasn't too clean on my idea, and I was essentially trying to do from 0 to 16. Right, and trying to go from 0 to 16, I was like trying to play around with 0 to 8 and 9. Essentially, this, I mean, maybe I don't even think I was that precise with this idea, but that's essentially what I was playing around with, and I couldn't get this to be right because it's always off by 1 somewhere as a result of, well, left and right is not the same size, and the way that we write this, it does require it to be the same size, right? And also as a result, that's also how I solved it, right? Is that I was doing some crazy things, so that I was able to solve it in this way, and I was able to kind of, if you remember the code, I'll put it up on the actual long explanation part. This is just the Larry brain dump version. Is that I was trying to get I was trying to construct the 7 answer so that we can do the query in a much quicker way, and that's basically how I did that. And for 7, it's just you go to 4 plus 3, and you can kind of think about it as like 2 plus 1 is equal to 3, right? And so forth. So you could construct the 7 recursively as well, which I did, but clearly it took more time and messy because like I said, I just wasn't practiced with doing binary search in this way. It's not something that I'm clearly and obviously I'm able to come up with it, but it just took like an hour longer than I should have, right? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about each problem, this problem. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.